am very excited about the event and being able to participate and take this time with the community. My name is Javier. I'm working in Microsoft in the Xamarin.Forms team and now also in the .NET MAUI team. And yeah, today I want to talk a little bit about .NET MAUI handlers. And handlers is the equivalent, more or less. We are going to talk about that with more details in the session, but it's more or less what was the renderers in Xamarin.Forms. And we know that that caused many doubts and questions about, hey, I will need to port all my code from renderers to handlers in .NET MAUI. How hard will be the transition between forms to MAUI? Will my existing renderers work in .NET MAUI? And that's the topic for the session. But wait a minute, because I need to be ready to talk about .NET MAUI. Okay, now I'm ready. And yeah, let's start sharing the screen and talking about .NET MAUI. So yeah, this is the topic, .NET MAUI handlers. Later, I think that 3 hours more later, we have a very nice session from David Ortinau talking about more details about .NET MAUI. But of course, I cannot start talking about handlers without do a quick introduction to what is .NET MAUI. So probably many of you know about it, know more or less what is the concept. So I'm going to try to move quickly about the .NET MAUI concept to jump directly to handlers and start talking about how handlers work, how to create it, how to port it, etc., doing as much demos as possible. But first of all, .NET MAUI, we are in the journey to .NET. This started 2 years ago in the Microsoft build. Microsoft announced that the vision is to have .NET to simplify the platform and the choice to .NET developers and provide just one single stack that supports the best brute solutions for all the modern workloads. And I want to talk more about the .NET vision from .NET 5 that has been released recently to the .NET 6. And the idea is to have, of course, cross-platform web UI, more investment in cloud work, continue improving, of course, in Azure services like stuff like speed, size, etc. But there are one very interesting point, and is cross-platform native UI. And when we talk about cross-platform native UI, we are talking about .NET multi-platform app UI or use .NET MAUI. That is an evolution from Xamarin.Forms. It's a cross-platform creating native UI. Yeah, we follow the same philosophy from Xamarin.Forms, creating native UI, but with many ideas in mind. But one of them is to improve as much as possible the performance, allow more possibilities with customization, of course, deploy to several devices, supporting iOS, Android, Windows, and macOS with API parity. That means that, for example, today in Xamarin.Forms, the shell is not working in macOS. That is something that, yes, will be available on .NET MAUI. And all this will be targeting .NET 6 and available at the end of next year. So, a quick summary of .NET MAUI. A framework for create cross-platform application for desktop, Windows and macOS, and mobile, iOS and Android. Creating SDK style projects. Today, in this session, I'm going to put all the focus about renderers, handlers, but .NET MAUI is much more than this. It's also be able to simplify everything with a single project, have support to command line, and be able to create projects using .NET install, .NET New, MAUI, And Xamarin.Forms and Xamarin Essential will move to .NET, the repositories and namespace. About compatibility, and this is one of the main topics that I want to cover today. The idea is to allow the current Xamarin.Forms developer to transition between Xamarin.Forms and .NET MAUI with minimal API changes. Probably, for sure, we'll need to recompile stuff using .NET 6, but the idea is to allow to continue reusing as more possible code as possible. And about Xamarin.Forms, we continue with support. Now we are in a period where we are putting all the focus in the stability, performance, bug fixing, and continue improving the current stuff. And that will continue after release .NET MAUI 1 year more ago. So what are the goals of .NET MAUI? First of all, quality. That's one of the points where we are working now. We are working on bug fixing, stability, and improve the quality, and we'll continue after the release of .NET MAUI with more quality releases. And .NET MAUI will be a organized project structure. We will try to simplify everything as much as possible. And when we jump to Visual Studio to see some demos, you will see that we have passed from several projects to one single project, from several files to stuff much more simple. And we will allow you to work also in a more simplified way with use a single project, etc. And we want also to standardize class naming and everything related with the structure, etc. Then other very big important topic is the performance. There are two main topics about performance. What is the startup time, that in mobile is very, very important, and we are putting a lot of effort and the focus on improve the faster, have a faster cool start. And also we are, and that's something that we are going to see with the .NET MAUI handlers, reducing the view nesting. And that's something that with MAUI will be possible because all the .NET MAUI handlers will be fast renderers. And if you remember the fast renderers in Xamarin.Forms, that means that we are not wrapping every control in a container to do stuff related with positioning or size. So for this view nesting is very important for game performance. Then there are, this is one topic that I will love to talk more in upcoming sessions, because it's designed and allow you to extend as much as possible the controls. And if you want to see something interesting today, you can take a look to the ready button available in Xamarin.Forms 5 that has support to a control template. So you can modify the template of the ready button control and really customize a lot what is possible with the control. And about platform, we had mentioned that before. We will support Android, iOS, macOS, Windows with feature parity. This is the .NET MAUI architecture. So your code primarily interact with .NET MAUI, and .NET MAUI will interact with .NET for Android, for iOS, macOS, and WinUI. That everything will use the .NET 6 VCL. And yeah, the supported platforms again will be Android, iOS, macOS, and Windows. So after that very quick introduction, if you if you want to know more about all these details, don't miss upcoming sessions in the event, because we will have more sessions about .NET MAUI with more deep vision of all these details. Let's start talking about handlers. I mentioned a lot handlers, and why? Well, .NET MAUI don't have renderers. Use handlers. So before jump to talk about handlers, some glossary of terms. First of all, the control. The concept is the same between Xamarin.Forms and .NET MAUI. Is the X-platform, the cross-platform UI element, for example, a button or a label. Definition is the cross-platform UI element that we are going to use in .NET MAUI, or that the element that we have been using in Xamarin.Forms so far until today. In Xamarin.Forms, we have the concept of the renderer, that is at the end the platform implementation of the control. this concept is not longer used in .NET MAUI because we are going to use the handler concept that at the end is used the responsible of applying some cross-platform requests for the platform control, and who will orchestrate and manage what are the requests is the mapper. The mapper will be a dictionary, in fact, a simple dictionary of functions that will map between the X platform API to the platform API, to the native controls, and will be managing the requests of the property chains to be able to notify the handlers, and the handler will be who will manage and enable the cross-platform requests. So, to know exactly why and what are we changing in .NET MAUI, let's talk a little bit about architecture problems in Xamarin.Forms. So everything is working, but of course we notice some parts that we can improve a little bit. So in Xamarin.Forms, the renderer are tightly coupled to Xamarin.Forms components. So for example, in the case of the button renderer, the button renderer have several references to the Xamarin.Forms button, which is a WinW object, as many of you probably know, that implement the notify property chain, and is the mechanism that we use to notify the chain of properties. So this is one of the parts of the point that probably is possible to improve. And the other topic is the Xamarin.Forms Registrar. And the Xamarin.Forms Registrar works fine. It's fantastic how easy it works, but it's using assembly scanning. And assembly scanning is really slow. So what happens internally in Xamarin.Forms basically is it goes through and scan all your assemblies, searching the specific renderer assembly attributes, and then you get it and automatically register it for you, and then you are able to use that component. So that's something that we can simplify, something that we can improve, and also is something that we can improve improving the performance. And the third topic that probably is possible to improve in the actual Xamarin.Forms architecture is there are some APIs really difficult to reach. In some cases, really complex to reach the native platform code from cross-platform code. So, for example, from a button, Xamarin.Forms button is not possible by the whole the hierarchy of dependencies is actually existing in Xamarin.Forms. It's impossible to reach directly the cross-platform code. So, for example, if you want to access the native layer, you have different mechanisms, you have different options, like, of course, create your own custom renderer, or there are other APIs like platform specific, and that's the code that you can see in the slide. It's a platform specific, but at the end, the platform specific is not doing anything special. It's just mapping a cross-platform property to a native UI. But not many people at the end knows that this kind of APIs exists, and is something that probably we can definitely improve. So, for example, the other point important about things that we can improve is definitely the custom renderers of the actual renderers architecture. So this is an entry custom renderer, and we can see several things that we can improve. So the actual custom render architecture relying on event handlers to orchestrate the behavior and the property chains, but there are a lot of boilerplate code, and you need to have many knowledge in order to manage all the events on all the renderer life cycle. For example, you need to know how to export a renderer and tie it to a core type. You need to know the type to inherit from. It's I need to inherit from an entry renderer. I need to inherit from a view renderer. What's the base class that I need to inherit? You need to know what methods to override. an element chain, an element property chain, what did in every case. And in every case, you need to know the parameters. What is all element? What is new element? And you need to know if you need to call your code before or after the base methods, or you need to know also that there are some small behavior difference between platforms, and that's not cool. So definitely there are points like performance, API discoverability, the life cycle, and some parts to related with the custom renderer that need a lot of knowledge that we can improve. So what are the motivations for the .NET MAUI change, mostly related with handlers? First of all, improve performance, improve in the container of dependencies. It's a topic that we are going to talk a little bit later. Avoid using assembly scanning or reflection at the startup to improve the startup time. There are improvements in layout to, for example, avoid to do a measure of elements that are not really necessary. And by the way, all the handlers will be fast renderers, so will not have any wrapper view, any parent unnecessary. So then API improvements, platform specific is often difficult to discover. And if you need to, for example, customize one button and extend one button, for example, creating a breaking border, for example, that is something that is not possible today with directly with Xamarin.Forms properties. Well, you can set today a background gradient, but not a border with gradients. So in that case, you need to create a custom renderer and have all the knowledge that we have talked about before in the previous slide. Homogeneity, not having the same API with different behaviors by platforms, and that happens a little bit with the custom renderers today. And simplify everything, the project structure, the handlers, service renderers, etc. So first of all, what are we doing to achieve these goals? The first thing that we are doing is the Cooper, the renderers. So the basic idea is invert the dependency. Now, .NET MAUI button depends on iButton, and as you can see, iButton is an interface, and it's what will be used by the button, but also by the button handler. So the button handler only knows about the interface, don't have any dependency with the .NET MAUI buttons, and this allows us to map to different types of controls, because the only thing necessary is use the interface, and there are any dependency with any specific .NET MAUI concept. And to achieve the performance, there are several ideas driving this, but one of the most important changes related with .NET MAUI and the handlers is improve the performance. So achieve a much better performance and allow to understand everything, how everything works in a easy way, mostly if you are a new developer using .NET MAUI, is what we are trying to achieve with this. So in Xamarin.Forms, it's a little bit hard to understand how to get the renderer, the life cycle of the renderer. We have seen a little bit of that life cycle and the events used in the previous slide. And also it's a little bit complex, as we mentioned before, also to access to any native element from the cross-platform layer. So what we are doing is sort of moving, it's like a reorganization, everything related with renderers into the cross-platform side to allow you to access things within the context of your shared application. So you can see in the slides a sample that, the idea is allow to register any renderer you want. So for sure there will be handlers registered by default, the label, button, all the handlers that will render these controls, but you can swap those in and out, and we are not going to use assembly scanning. So it's a very explicit way to register, but in next slide, we will see how we are going to manage all this with application host. I will talk about a little bit about dependencies container, and we are going to manage already with registering. But in summary, we are not going to use anymore assembly scanning. There will be only one possible case where we will enable you the option to use assembly scanning. But by default, we are going to register renderers in this way. We are allowing to register a label with the label handler, and of course, the code sample from this slide works with multi-targeting, so you can include this code in cross-platform code, for example, in the application definition code. And the idea is that is zero runtime assemble scanning. More chains, more important chains. Remove confusing APIs. We have talked about that before. This example refers to platform specific. So the main idea is you will have access to native bits from the cross-platform standpoint. If I have, for example, .NET MAUI label, I can use access to the native view from cross-platform code. We are going to play with that a lot in the next demos. And yeah, you can use compilation directives or create specific platforms files, classes, to access to these controls and use customize and do whatever you want. So this is what we was doing in Xamarin.Forms, and the idea behind that is, we are going to see that, but you can access to the mapper, and the mapper, remember, is a dictionary of functions, so I can access to any registered property in the mapper, and here in the handler we can access to the native view, as you can see here, handler.native view. And if we are, for example, in Android, cast to the correct native view and directly access to native APIs from the native view. And this is possible using compilation directives or creating specific class by platform directly from the cross-platform side. So stuff like platform-specific that at the end is used setting a property from the cross-platform side to the native side will be much simpler in .NET MAUI. Okay, before talk about the main .NET MAUI handler classes, like the classes that orchestrate everything, let's talk a little bit about the current Xamarin.Forms render implementation and the current interface used in the renderers is visual element renderer. That is what drives all the renderers at the native level. This is how, for example, the layout system interact with the native control and gets basic information like what should be the size, when should update a property. So you can see, for example, methods ready with get this size. Here we have the element property chain, when the element chain is where you set the native control. Element property chain is where you detect when a property change and update a property based on these chains. And let's compare the chains between Xamarin.Forms and .NET MAUI. So visual element renderer is the Xamarin.Forms stuff, and the new one is view handler. If you do a quick comparison between the two interfaces, you can see that are very close, are much the same. It's a new interface that allows to represent controls using the new implementation, but not crazy change. For example, set view is at the end the set element, and for example, element property change is update value in view handler. So we are having a new interface, view handler, that is the interface that any handler will implement. And then we have iView. Remember that now we are going to use interface to represent the views, and all the handler will not have a direct reference to the .NET MAUI label. Will have the reference to the A label, the interface, and all the interface will inherit from the iView interface that you have here, where you can see basic stuff like frame to set the size, if a parent methods like arrange or measure to calculate the size or positioning, etc. So the current rendering strategy in Xamarin.Forms, I'm going to compare the ways how renderers strategy works in Xamarin.Forms and .NET MAUI. And in Xamarin.Forms, there are some, you probably have seen that if you have previewed some Xamarin.Forms renderer, or if you have created your own renderers in some case, you have these huge if statements where basically we are detecting when a property change, and if the property change it was one specific one, we have some methods to update the native control with that property. Remember that today in Xamarin.Forms, all these methods are private, so you cannot access to that. And with .NET MAUI, the strategy is a little bit different. So it's more functional based. The idea here is that all the update methods we have seen before, that was private, will be moved to extension methods. And you can see here, for example, the text view extensions and the update text extension method that is public. And why we are doing that? Well, we want to open as much as possible, and we will public methods in case you will be able to apply and use these methods directly in your own handlers. Also, it's very powerful for cross-platform because since the way everything works is create a standard API across all the platforms. For example, the label extension you can will be available in all the platforms, iOS, Android, Mac, etc. So you can create a single class and do something like that when mapping the map test. Use the extension, and then every platform will use the correct extension. In this case, the test view extension, and will update the test in every case. Finally, remember that who orchestrates everything and who notify when update a property is the mapper, and the mapper is just a dictionary of functions. So before, when you saw the Xamarin.Forms property change stuff, what it was doing is just mapping strings with methods, and is what the mapper more or less will do, but standardizing that to use a structure and something much more pluggable to allow you to extend. So at the end, a quick summary of what we have seen so far, and now we are going to jump to a demo very soon. The handlers are just an organization. We are creating some new interfaces, as you have seen close to the previous one, to allow some basic changes in how the handlers are created, and also how the layouts manage the native views. We are improving also the layouts to achieve more performance. And now, for example, if you have take a look to the previous interfaces, we are using now a set frame. We are being more strict with how we manage size. Yeah, we really are getting some initial results improving the layout. So we are taking all the renderers and converting now to something, a new API, more consistent, and searching several improvements that we have mentioned before. But mostly we are trying to improve the performance. We have trying to avoid consistent APIs errors, and we are trying to simplify how you manage the handlers and how you create it, and also allowing more possibilities extending that we are going to see now. This is how you create a custom behavior. If you want, for example, to customize an entry color, in this case is iOS, you need to create, in the core project, in the cross-platform side, you need to create abstraction, your entry, and then in iOS, in the iOS project, you need to create your entry renderer, where you need to override an element chain, and then if the control is not true, you, in this case, finally can access to the native control. But in .NET MAUI, you will work in this way. You have the mapper. You can directly include, create a mapper for the entry, and here we are going to map all the properties with a static method. Why this is better? Well, first of all, you don't need to register the renderer like you was doing here in Forms. Then you don't need to know anything about what is the correct method. It's on element chain, on element property chain. No, it's the method that you assign in this property. Is map background color. Then we simplified also the naming of the basic stuff, like, for example, virtual view will be the abstraction, the virtual view, and native view will be the native control. So in your map background color, you don't need to call any base methods or worry about the order. And every render is consistent. Everything will work in the same way in all the platform. You know what is native view. Native view is the native control, and you don't need to know anything else. And then, yeah, you can access to the abstraction, that is view, and then update everything in a more easy way. But the most important thing, and we are going to see that now with some samples, is that you can extend everything in a much simpler way. For example, from your cross-platform code, if you want to customize the native, for example, the native button in Android, you can use compilation directives or create as a specific class for Android. You can access here to the native control, as you can see here, and directly map the text color as you want with your own logic directly from the cross-platform side. That's something that, yeah, today is not possible with Xamarin.Forms in this way. And I think that that's one of the awesome things from the handlers. So let's take a look to the handlers, and let's see. I will try to do as quick as possible how to port a Xamarin.Forms renderer to a .NET MAUI handler. And for that, I'm going to open Visual Studio. I'm going to just a sec. I'm going to open a solution with the handlers. Loading. Okay, here we go. So let's take a look to what we have here. I'm going to close everything. If you have taken a look before to Xamarin.Forms, you know that we have a core project with all the elements definitions, and then we have a platform project, and for every platform. In .NET MAUI, we will have a single project where in core we will have the interfaces. For example, what's a button? A button, it's a little bit the font. Let me know if I need to increase a little bit more. I hope that everything looks very well. So a button have the button events: press, release, click it, and inherit from itext. Itext is including the text properties, the text color, the font, the text transformation, and at the same time inherit from other interface like iPhone that include all the font properties. And at the end, the final element is iframework element, that is the base interface to define all the elements that includes all the properties that will be applied across all the elements, like the background color, the frame with the size positioning. There are some events like array, measure, invalidate the measure of the range, etc. Let's take a look to the handler. That, of course, is included in the handlers. I'm going to increase also the size a little bit of this part. I hope that this looks well. So we have the iView handler. iView handler, remember, we have seen this interface before in the slides. So if I take a look to the base, view handler is abstract view handler, and the most important method is set virtual view. Here is where we set the virtual view, initialize the native control. Then, if the native control has some default values, like some default colors, for example, here is where we are going to set that. And finally, we are going to use the mapper to update the properties in case necessary. So if we are going now to something like, I'm going to slider, for example. This is the share class between all the implementations, all the supported target. Here is where we are creating the mapper. Remember, the mapper is a dictionary, it's a simple dictionary of functions where we are mapping the properties from the interface. Again, the slider is defined by an interface with some single properties and the necessary methods. And going back to the slider, here we are mapping all the properties with some methods. We could implement all these methods directly here in something shared between all the platforms. I'm going to explain that now, but let's take a look to that. I think that hopefully everything is much more simple to catch the idea more quickly than using the actual renderers architecture in Xamarin.Forms, because remember, we have seen before the abstract view handler, and here is where we was creating the native view, connecting handler, set defaults. This is some methods that we can use in our handlers. So for example, what's the handler that we need to use to create the native view? Yeah, create view. What's the best way to, for example, set a listener to, in this case, listen the part chain? In this case, well, when we connect the handler. If we want to dispose or remove this listener, is when we disconnect the handler. And if we have some default colors, we have the setup defaults method to do that. And then what is the other thing that we have? The map methods are purely static methods, and we are used when we set up the control. When we set up the control, all these methods will be called. And when a property change, for example, the maximum value, this specific method will be called. And we talked about, hey, we are moving everything to extension methods. So what is update maximum? So it depends. Update maximum, we are in the Android implementation. If we move, we move to the slider extensions class. It's a set of extension methods where we can update all the basic properties mapped and available in .NET MAUI, like the minimum, maximum, the minimum track color, the maximum track color, and in this way is how the handlers work. Now, if I move to a sample, so the sample is using multiple projects. Remember that there are also forks to have a single project. Okay, so this is .NET MAUI application. And let's see some cool things about the handlers and .NET MAUI. And I don't know how I'm going with the time. Not sure if write the code or copy the code directly. Not sure if start writing the code and then maybe copy if I have no time. Not sure. Okay, I'm going to try to use write all the code, and if I'm writing quickly and I'm good with the time, I will use copy some snippets that I have. So, okay, let's start with that. So what happens before in Xamarin.Forms is I need to customize some button, for example, to achieve a border with a gradient. Yeah, probably many of you will go for a custom render, but take a look to that. We can access here, and remember, this is in this case, it's a library, it's a .NET standard library, and we are in cross-platform code. So we can access here to the button handler, and this is now this namespace. And then I can access to the mapper that probably at the end will be directly used mapper, but for now it's called button mapper. The mapper, remember, is a dictionary. So now, one interesting thing is that I mentioned that when we initialize the handler, we set up and invoke all the methods mapped in the mapper. So I can create something like my custom property. And yeah, then I will have the handler and the view. So here I can do something like var the native view will be handler native view, because remember that in the iView handler, one of the properties is directly the native view. So going back to the application, if I launch this application, for example, let's use iOS. It's not a super excited application, but I think that is enough to catch and know all the basic ideas. Come on, building. So I think that for the NES, I think that I'm going to copy code to accelerate a little bit. I have many demos. So, okay, if I put a breakpoint here and we'll launch again the sample running, and here, as you can see, what we have here is an UI button, because we are executing this in iOS. And yeah, when the mapper is the handler is initializing and set up all the properties in the mapper, this is invoked, and we can get something like that. And if I move to my snippets a little bit, I'm going to copy some of the ideas. So other thing that we can do is something like that. So instead of access to an embedded property, I can access to any property from the interface. So for example, background color, character spacing, color, etc. You can access to the background color. And remember that we have the extension methods. So if you want to set the property using the current .NET MAUI implementation, you can use these extension methods. But if you want to do something in a specific platform, for example, in this case in iOS, you can access to the native control. In this case, it's an UI button, and you can access to, of course, everything related with the native button. So the same happens with other controls. For example, I can access to the slider. In the case of iOS, I can use update the background color, and in other case, I can use the native slider, update background color, and pass the view. What's that? This is the extension methods. Are the extension methods that we created, and for that we are moving to extension methods because that allow you to not only create your own custom logic, but if you want, for example, to update the background color of the button at the same time that you update the border, but you want to continue using the default logic that the button have, you can perfectly use these extension methods. In the same way, you can, for example, create a new class, create a custom button class, for example. And I'm going to copy again and explain the code to accelerate a little bit. What are we doing here? Okay, we are creating a button that inherits from the current .NET MAUI button. we are registering this button. Remember, we are not using any more assembly scanning, so you need to register the handler in this way. But we are registering the custom button using the button handler, so we are not going to change nothing special. The only thing that we are going to do is when the background color change, we can do something specific. But what if you want to include a specific property? So yeah, you can do, for example, you can create a shadow color property of type color. And in this case, in the case of iOS, using your custom button, you can access to native APIs using, in this case, the button layer and setting the shadow color, opacity, etc. Of course, passing the shadow color property and converting to a native CG color. And finally, of course, you can go to your application here. And for example, here in the vertical stack, I can include the new custom button, setting the property that we created, that is the shadow color, to color red, and a text, for example, my awesome custom button. And if I launch this application, you can see that from cross-platform code, we are accessing to native code, and that's awesome. I have some errors somewhere. Oh yeah, the native slider is not existing here. Okay, yeah, I wrote this sample, but need to create the native slider in other platforms. This is only created in the case of iOS by the compilation directive. So if I open again the simulator, launching the application, now we are going to see that we have some buttons. For example, remove the breakpoint. We have some buttons like here and here, but you can create your own custom button. In this case, take a look to this red shadow using native APIs, and I'm doing that from a cross-platform side. That's awesome. That's fantastic. Of course, you can create your custom button class, then your custom button .ios, .android, and not use compilation directives. And you can create your own mapper if you want to create something custom or specific. And in case you want something very, very specific, like in this case, that we are just only adding a property, but we are reusing everything from the button handler, you can just register your controls with one of the existing handlers. And let's continue and move on. And what I'm going to do now is try to very quickly create a handler based on a renderer. So what I have chosen is a very, very, very basic renderer that maybe you have used sometime, and it's the activity indicator. Why I have chosen that? Well, because it's very simple. It has only a color property and a Boolean property which is running. So we can go to the activity indicator renderer, and we have the renderers in every platforms. For example, we can go to iOS or we can go to Android. This is iOS. So this is the renderer. On element chain is where we initialize the control. We set and invoke some properties to set the default values for example, the color. And if it's running, remember that that's not necessary anymore in .NET MAUI, because when we initialize the handler, we invoke the mapper invoke to all the properties directly. And then only once it changes, that is the equivalent to this property chain. And then we have this update color and update running. So basically, what we are going to do is the following. I'm going to copy paste as quickly as possible, explaining at the same time that I'm creating. So this is the activity indicator handler. The first thing that you need to do to define, in this case, .NET MAUI element is create an interface. For example, in this case, the activity indicator. Activity indicator will be an interface with two properties, remember? So take a look to that. We are not using bindable properties. We are using simple properties. Remember that we are with some experimental ideas in the heat, like support more than MDBN or SymView. And well, in this case, we are, no, it's not this color. We are creating single properties. The next thing that we need to do is create a control that we are going to create here, a new control. And the only thing that need to do, the only thing that need to do this control is implement the interface. So we have something like that. And so now I need to resolve this, and I need to resolve this. Why you are not solving the namespace? Okay, so now I have the control, and then we are going to create a handler class. So in the handlers, we create a class, a folder called activity indicator. It must be something like that. Okay. So now I add some classes like the activity indicator class. The activity indicator class is where we create the mapper mapping the activity indicator to the handler, and we will map the activity indicator properties, is running and color, to some methods. And then we need to create the implementation in every platform. But take a look to that. We are mapping these properties directly here, while in the slider, the map methods was in every platform. So you can do that in every platform if you have some specific logic or properties or something, some stuff related with some specific platform. But in this case, if you are using exactly the same properties and the same extension methods, you can define these properties directly in the cross-shared code. And then for every platform, what you need to do is create the activity indicator handler for example, Android. And here, the only thing that we are going to do is, where are you? Here is just create the control. Why we are just creating the control here? Because we don't need to set some default values, because we don't need to do something when we are connecting or disconnecting the handler. So the only thing that we need to do is create the native progress bar, and then all these update is running, update, color, extension methods will exist, of course, here in the platform folder. In Android, we need to create activity indicator extensions, activity indicator extensions, where, yeah, we are going to implement something like this. So if you take a look what I have here in update color, if I go to the activity indicator renderer, we are doing exactly the same that we are doing here in update is running and update color. We are moving that to these extension methods. These extension methods is used by the methods, the public static method that is invoked by the mapper. So it's here in handler activity indicator. We are mapping is running with this map is running property, and this is invoking the update is running extension method. So we are just reorganizing things, but it's very important because yeah, what we are doing here is create a view renderer. Remember, a view renderer is not a fast render. So, for example, the difference between this renderer and the handler is important at level of performance, use refactoring and moving stuff between the renderer and the handler. So this is more or less how we can port an existing renderer to a handler. But yeah, I can imagine what you have in mind. So your probably question is, yeah, Javier, that's cool. It's not crazy, it's easy. It's easy to understand because we have the create view, and of course we are going to create a native view. We have the connect and disconnect where we can subscribe, unsubscribe, etc. And we have the setup defaults when we can set up defaults. And yeah, the mapper concept is easy to understand. It's mapping to some methods to map the properties. And yeah, you are using extensions. Of course, if you want, you set all the logic of your native control in, for example, in the activity indicator, in the activity indicator.android class. You can just set all the code necessary to update the color there, but we are using extension methods used to allow you to access to the default logic of the handlers, like we have seen in the other sample. But yeah, it's fine. But do I need to convert my current renders to handlers? So there is a PR. Well, there are several PRs interested related with MAUI today. You can take a look to that in the Xamarin.Forms repository. One of them is this one, render to handler and handler to renders. This probably gives you some ideas. And I'm going to open other solution. In this case, this one, where I want to show you something really interesting. Where you can see how we are working to allow you to use your current renderers in .NET MAUI without big change. In fact, without any change. So what we are doing here is create this class, renderer to handler sheen. So what will happen is the following. When in MAUI, when we create a new handler in this way, if the renderer is a view handler, implements the iViewHandlers interface. Remember, this is the new interface introduced in .NET MAUI that all the handlers is using. We are just return the handler because it's so far a view handler. And if it's a visual element renderer, remember that is the interface that all the renderers implement in Xamarin.Forms. We are going to return a render to handler sheen. What's that? Well, it's this class where when we receive the renderer, we are going to set up the renderer. And to set up the renderer, what we are going to do is access to the element to get the view, set the handler, set the virtual view. So what we are doing is at the end creating the handler from the renderer. And in this way, what we will allow you to do is something like this. I'm going to open other solutions. Yes, as you can see, we have a lot of prototypes, tests, and samples. So opening other solution where you have seen so far how we register a new handler. And now we are going to see how we can register in the same way a renderer. Come on. Come on. So here in the sample, this is not my app class, right? Oh no, I opened the wrong one. This is the solution that I want to show you a little bit later. So I'm going to open another instance. And now let's take a look. So here in the application, you can see here that in this line, we are registering. In this case, we are using the label mapping to the label renderer that is available in Xamarin.Forms. And if I comment this line and comment this, in this case, we are using the label renderer when you use the label. And if I do that, I'm going to use the label handler. So you can register using exactly the same way, but this is not probably the way that you will use in the future, because I want to talk also about .NET MAUI and dependency injection. So .NET MAUI will use the host concept similar to what is in, for example, ASP.NET. This will allow you to use the containers and the provider for all handlers, and also to do some configurations with app files and other features like register service or login extensions, etc. So the app builder will be hidden by default. I will show you how, but we will allow you to override it. And in this way, you can extend and register native service, configure login, register new handlers, etc. So for example, using this way, you can register handlers like that. So application, create the default builder. Here you set and initialize your application. And here, using register handler, you can register iButton to my custom ping button handler. Okay, that's okay. Of course, there will be more options like register handlers if you want to register several ones. So in .NET MAUI, we are going to use the Microsoft dependency injection to register custom handler. This is available in this PR 12460. And while in Xamarin.Forms you use the sport renderer attribute to register a renderer, internally, remember, Xamarin.Forms use assembly scanning to search between all the assemblies and catch and register the renderers for you. In .NET MAUI, the assembly scan will not be used by default, and we will allow to register the renderers manually in this way. You have seen this way, but if you want, this, I think this is really interesting for third-party vendors, and in some specific case, if you desire, if you want to allow in some desired case where you want to register the renderers using assembly scanning, we will have some options like configure renderers, options, scan for renderers attribute, true. So in that way, we will enable, and probably this will be the only case where we will enable the assembly scanning, and probably we will investigate if we can achieve that not using assembly scanning and using C# generation code to generate the necessary code in this case. But in that way, you can just register all your renderers. The syntax is not yet closed, and this is like on to cool chain, but you can do that in this way. So I can just execute this sample, but I want to allow some time to questions. But at the end, this sample is use a benchmark test where we are using hundreds of labels, and we measure how much updates we can do in the label every second. And yeah, I'm going to show some GIFs later about that, but the only thing that I'm doing here is just swap between using for the label or the label renderer or the label handler. So yeah, the quick answer to will I be able to continue using my renderers without big change in .NET MAUI? Yes, you can. But you will need to choose between convert to a handlers or still use your own renderers. This is something that will fit different between the situation. Using the handlers, of course, will require some time for code conversion, and every handler will be equivalent to a fast renderer. In addition, will be managed in a different way also by the layouts, and the performance will be better. And also, if you remember the samples that we did with the button, accessing to the native button from the cross-platform layer allow much more extensibility possibilities, more options. By the way, using the render, you don't need to do. You don't need to do big change. Don't require change. You don't take advantage of any of the handlers improvements like performance extensibility. But okay, that's okay. The sample that I had before, where I can swap between the label renderer and the label handler, is this test, and you can see that .NET MAUI is like between 3-4 times faster than the Xamarin.Forms one, just swapping the label. And that's why, because, how we create the handlers, how we manage it, fast renderer, how the layout get the size, and when need to measure and when need to position again, etc. So, yeah, you can mix renderers and handlers in the same .NET MAUI application, and that's the architecture. We will use interface for describe each control. Then we will have handlers that are controls without no bias to MVU or MVVM, and then the frame will enable controls to use with some patterns. And the .NET MAUI work is re-architecture, new methodology, new organization. We are working also in re-architecting the layout system to improve the performance. We will remove obsolete and slow renderers, remove everything with pre-app combat, unify overlaps between Xamarin.Forms and Xamarin incentives that in some specific case on some renderers happens. We are going to use the Microsoft dependency injection extensions to allow you to register service, everything that we have seen just before. Of course, that will not stop you to use your favorite library to register and manipulate your dependencies and your container. So we will drop, of course, .NET pre 2.0 support, unsupported vendor APIs, and well, we will work in more stuff. Is everything about .NET MAUI about handlers? No, I can talk about handlers during hours, but we will do much more. And we have many sessions after this one, and Debbie Orti now will talk a lot more about other very excited stuff, like for example, very excited about control templates and the nest shell, and etc. Again, roadmap. Now we are working in .NET 5 release for December, and .NET MAUI will be something that will happen on next year, in November of next year. And I don't know if I'm good in time, but if there are any questions, doubts, feedback, I will be more than happy to answer anything.